going to talk about test automation for Bluetooth connected IoT devices. Kind of specific, right? But I had to make a pretty good scope for this. I cannot really talk about IoT in general. This is more for the mobile app powered IoT devices, this talk. So let's quickly recap the abstract. So IoT is growing at immense rate. It's coming. It has been trending for a while, and projections are showing huge growth for the IoT. And this also includes the consumer devices, so wearables, all kinds of smart devices, and people need to make apps for these devices. And of course, the question is, how do we do test automation? How do we assure the quality of these apps? Because now we have an extra piece with the mobile device. How do we make that efficiently? So this is kind of the premise for the talk. To introduce myself, my name is Lasse Häll. I'm a solutions engineer at Sauce Labs. I've been in test automation for roughly 4.5 years. When I started just started with scripting for Robotium, something very simple. Started working from there, and back in that time, Appium was quite fresh as a framework. But I've been following the growth of the framework from those times since version 1. And I really do like the way it's very flexible as a framework. Of course, there's all kinds of issues you probably have you come around when you start using the framework. But once you know how to use it very well, then it can do very powerful things. So with Sauce Labs, I've been working with various size of companies. So what I do is I'm the person who introduces the service to new companies and introduce like what does the cloud service do? What's the point? Why does the company exist? And that means that I've been evangelizing the cloud approach basically for test automation. And 2 years ago, when I joined Sauce Labs, that's when Sauce Labs shifted their focus from the US markets also to Europe. So now we have like a full-blown offices here in Berlin with a full support team, sales team, marketing team. So we're for the past 2 years, we've been working on growing the user base also in Europe. So how many of you have heard about Sauce Labs before? Is the company familiar? Couple hands. Which one of you have ever used the service? Have you ever trialed it or? Okay. Good news for you guys is that this month we're bringing the release of European data center for the VMs product of Sauce Labs. So far we already had the real devices cloud available in Europe. Now we're bringing also the virtual machines to Europe, local data center in Germany. So that's going to be very, very useful for various reasons. One of the things is latency. It's going to be much more performant. Another thing is all kinds of GDPR-related compliance things that companies really need. Just check my notes. Right. So originally, when I started at Sauce Labs a couple of years ago, I was really excited actually to join the company because I knew that people like Jonathan Lips, Isaac Murchie, these main contributors to Appium, these guys actually work at Sauce Labs. So it was really for me because I had been using Appium for a couple of years back then to be able to actually have a direct contact with these guys and be able to kind of throw ideas to these guys, because Appium is an open source framework, but we have multiple employees at Sauce Labs who do full-time work just for open source frameworks for the community of Appium and Selenium, and I thought it's really exciting to be able to actually work with these guys. Did you actually know that Sauce Labs was basically the first cloud-based grid for Selenium? Basically, the creator of Selenium, Jason Huggins, was one of the co-creators of Sauce Labs, the company. And his idea was to, now that Selenium framework existed, he wanted to build the cloud grid so that they could upscale the use of Selenium to a global scale, so that you have a dedicated service just for the grid, so that not everyone have to necessarily build all these things by themselves, but there's a turnkey option also for starting your cross-browser testing experience. So that's basically why Sauce Labs was founded 10 years ago. Of course, back then Selenium wasn't yet the main test framework. It was really fresh. Back in those days, 10 years ago, test automation was really mainly being used by proprietary tooling. Those of you who have been working with test automation back then might remember Mercury and this kind of proprietary test automation solution. So you had to buy licensing for the tooling, for the software, to be able to automate your apps. And a fun fact about why Selenium is called Selenium is because mercury poisoning used to have one specific cure, which was selenium. So I think that's a funny story, like why they came up with the name was to cure the mercury poisoning that's coming from the proprietary world. Cool. So my agenda for the talk, let's quickly take a look what I mean with Bluetooth connected IoT devices, what's the about the growth of the market and some examples of the devices I'm talking about. And then I'm gonna talk a little bit about like how does the cloud provider come into this scene of helping you with test automation, and a little bit about like what's the difference with building your own grid, purchasing some kind of on-premise solution, or using the cloud. And then finally, I'm going to talk about where we are today when it comes to IoT related testing. So, as I mentioned, there's huge growth in the IoT space. Of course, the consumer devices is only a small part of it. Most of the IoT is all about the different kind of sensors, smart sensors here and there, all kinds of things. And the projection here is that from 2017 to 21, the projection says that the whole space is going to grow almost double the $520 billion per year. And we noticed that there is fairly big amount of consumer devices in that space. And I'm sure we all know these different kinds of mobile devices that exist in the space already. So we all, one thing I've noticed is that mobile app test automation is becoming quite mature. It feels like a little bit of like everyone is doing it now, whereas 5 years ago, not so much. So this tooling for mobile app automation is becoming mature, and now we're heading to the next thing, which is how do we deal with the IoT devices. And basically, the idea here is how do we do quality assurance for those apps that are dependent on the device. So one choice can be mocking. That means basically you just make the app assume that the device does as expected, and let's just move on. Let's forget about the actual device. Let's mock the responses. So that's really good for scaling your testing and quickly check the functionality of the app. Of course, it's not enough for the end-to-end in that case. It's one of the best practices to do the full end-to-end situation as well, because there could be some issues you do not find from the mocked situation. But the problem with the end-to-end is it's complex. How do you control an IoT device? This is very problematic. There is no Appium for IoT these days, so you cannot there's no easy way to do like connect a Bluetooth device, disconnect, and then check that the app, the device and the app are behaving correctly. So there's a lot of things to think about there. Now, some examples of these mobile devices, different kind of smart speakers, smart locks. I'm not sure if that's a smart idea, but smart locks are also a thing. I can only imagine the situation where the connection doesn't work and you don't have a physical key. But it's a thing as well. Smartwatches, and yes, this was a surprise to me. E-cigarettes also are coming to the IoT space. The first one I saw was basically an e-cigarette that you can make a phone calls with and play music. I don't know why, but it's there. A little bit more sensible solution was that you can control the amount of nicotine in the product and do your own flavors. So that was maybe a bit more sensible use for like more smart way of doing e-cigarettes. So you can control and see how I guess it does metrics on how often you vape. So that's that. And then we have different kinds of sensors. So all kinds of smart home devices. And all of these devices need an app to work with. And that must be, I'm kind of happy I'm not in the shoes of being the QA tester who needs to automate this, because it's not going to be easy. And most likely, most of the testing these days with these are done manually, the end-to-end cases. But in any case, we've been in contact with a couple companies at Sauce Labs, and we're working on some projects right now. I'll talk a little bit more about that later. So another choice from the actual IoT device is to use some kind of a generic version of a Bluetooth device. So this is kind of halfway to mocking. So you have a device, but it's not the end product. It's not the smart speaker. In this case, it's a very generic Bluetooth device, which you can program to do the same responses as the real thing. So it's could be one solution also here, more simpler than the actual end product, which would be custom in every case. So far, we haven't seen much adoption for this method, but I actually expect that we are going to see some kind of more generic use for these devices, because this is easier to standardize than just working with all the different devices. So I would say that this is interesting to follow if we can see some very good solutions around that. So next up, we're going to talk about how test infrastructure providers come to play here. So that, the idea is that you shouldn't need to build every single thing yourself. It's better that you have some kind of solution that helps you speed up the testing and helps you focus on the app development. So you don't need to spend all your time figuring out how to automate this whole thing. And the main value proposition from cloud vendors for test automation is that we're trying to help companies move to the continuous delivery space. So if we look at the graph, we have the old way, waterfall, the old style of slower and more planned development. And we're pushing more and more companies to go to continuous integration, continuous delivery, be able to do fast innovation, fast testing, fast development. You might have seen similar graphs before. So this is the whole idea of being agile, is that you start with planning, you code the feature, you build it, you release the new version, deploy, monitor the production version, and then it goes in. It's a continuous cycle, right? And testing needs to happen also in this cycle, not at the end only, but also as early as possible. So this is what people say is the shift testing left trend, which means we want to do as much testing as we can on the code level. It's like a funnel. So most testing at the very beginning and pushing more and more testing early on, because then you will notice and recognize the issues in your code much earlier. Because if you find them out after the release, you're in trouble. You don't want that. That's a big. It's an issue from the user perspective, but also from the business perspective. You're losing money when you're introducing issues a lot. So this is the automation journey we usually see with companies and customers of ours. One of the things we usually ask at the beginning is where do you find yourself on the automation? Are you still doing mainly some kind of legacy testing using one of these proprietary tooling, or are you doing only manual testing so far? And I think we're slowly starting to see that majority is going through the beginning and is getting into the intermediate automation. So this is very interesting, because I think we're now starting to see late adopters come in to the CI/CD. Everyone's starting to realize, yes, we need to do the digital transformation. We need to get there. And when you are able to do continuous testing, these are the main benefits you get from being agile and doing continuous testing, is that you're able to effectively develop your apps faster. You get new features in much faster, you get bugs fixed much earlier. which means you're increasing quality of your apps, and it also means you're improving efficiency of your teams, which means you're saving money. You probably don't need to spend so much time debugging your apps, spending very expensive developer work on doing that work, and just getting to the market much faster. And the companies that get it right are able to do focus on these things. So focus on innovation, release frequently, get fast feedback from their development cycle, release with confidence to customers, and it drives the company growth when you're able to do this efficiently. Some examples here of some of the companies we work with is, everyone knows Slack. Slack uses Sauce Labs as well to speed up their automation, be able to have reliable test results all the time. Twilio and Walmart are also very interesting. Walmart especially, we noticed that Walmart is actually, it's a retailer, it's a shop, but they're also a digital company. They're doing all kinds of interesting things with mobile apps to enhance the experience of going to the shop. So they're being very innovative, and they have to, because otherwise other competitors like Amazon are just going to take all the market. So every company is a digital company these days, right? So this is what we see. And when we take a look okay, test automation, should I use cloud? Should I do on-premise, build my own grid? So there's certain important things why it might not make sense to build your own thing. First of all, the maintenance work. There's constant updates. I think Chrome browser itself does 6 major releases every single year, and that's just one browser, so you need to keep up with the new releases. So there's constant maintenance work going on. That also means that you need to put a lot of people's time working on just maintaining these different updates and maintaining the infrastructure. And that work is not relevant for your business. It doesn't help you innovate. It's just something you have to do, right, to enable the development work. And when you build your own grid, we typically see that, first of all, I'm underlining this coverage is where you're lacking. When you build your own grid, you probably start with, if it's desktop browsers, you start with, okay, we have Linux containers and Chrome. We're doing headless testing. It's really cool. It's really efficient, really fast. But you're testing Chrome on Linux. How much of your business comes from Linux users? The consumer market is not on that platform. Yes, Linux is the best way to employ business services and all that stuff. But the consumers, they're using Windows to access your websites, and you're not testing that if you're only on containers. Containers are amazing for the scale. You get really fast feedback, and they're really important for this early phase of testing. But you need to do cross-browser testing as well, cross-mobile device testing. You need to be sure that the most important platforms are working, because you're losing money if let's say Amazon, you're trying to do a checkout and you buy some items. If that doesn't work, you're literally losing money. This is something we noticed with one customer of ours. They were not testing Safari at all until they started using Sauce Labs. That's the most common thing that people are missing, because building a grid of Mac OS on Safari, that's the most kind of the thing that people usually, well, there's not enough users. We probably don't need that. It's only 5% of the users. Maybe it's not enough. But when you're a big company and you have a lot of revenue, 5% is a lot. That's millions of dollars of revenue that you're losing if it doesn't work. And this is one example we had with a customer of ours who they had an issue with Safari. It didn't work. They couldn't do the purchase on their web shop, and they could easily calculate the revenue lost when it's not working on Safari. So they had a business case for it. So it made sense to start using Sauce and use the existing Safari platform that's available there. And last thing for when you're building your own grid, so coverage could be one problem with your own grid or on solution. Scalability, well, depending on the product, it can be very scalable, or it's really tough to scale. If we talk about mobile devices, it's really tough to upscale your mobile test out. You need to buy new iPhones a couple times a year, which all cost like over $1,000 or euros each, and you have to keep going through that whole cycle. And of course, updates. So you either do them and spend time on them, or you decide that hopefully it's fine if we update once a month rather than always when possible. So there's some limitations that come from the fact that people are lazy, right? It's just the nature of people. And with these limitations in mind, it's quite common that you cannot trust the results you get from your automation. Your build might always be red, and it's like, yep, but it's that one case which sometimes fails. Let's do a retry, or let's just go with it. You don't really care about the green build anymore. It's always red. So coming to mobile devices are flaky. Like we're talking about the real mobile device here. They're all very different. Every single manufacturer has their own version of Android. They're not doing stock Android very typically, which means they behave a little bit different. So mobile devices are challenging to make a grid out of. And routing is not an option for these mobile devices for various reasons. It's not a credible end-user device. Your customers do not use rooted phones by majority. There's a certain niche of people who do, but it's not the main user of your app, most likely. And then just maintaining those mobile devices is even more difficult than existing like desktop and virtual device platforms. Mobile devices, it's basically a black box. You don't have like a full control. And then you could build your emulators and simulators grid, but that alone is not enough. So what I'm getting here is that there are services that have all of this available. It's important to consider how much time do you have for building new things. Or should you use one of the services that exist? So let's see how much time I have. At 23 minutes. Yeah. So let's talk about where we are today, related with the Bluetooth IoT devices. So right now we're in POC mode. So the first proof of concept where we're actually aiming to do the full automation of a mobile device together with the custom real IoT device. We're doing a proof of concept with that right now. Hopefully in the next months we're able to actually also give some news about like how that went, and hopefully we're able to kind of get into this space and offer solutions also for this use case. Second POC is also already planned, so we have seen some interest on this side of things. So far, it took tons of planning to get here. Hardware delivery installation, just figuring out how do we get the correct devices into the data center, what do we need to do to install those devices, what do we need to consider from the network layer. It takes a lot of planning. It's not like you just drop it there and it works. There's a lot of setup time, setup work that you need to do for it. And the main focus for the solution is still, we're not really testing the IoT device here, we're testing the mobile app. That's the point of this whole setup. Testing of the actual IoT device, that should probably happen at the manufacturer's side. They need to ensure that it's correctly built. We need to ensure that the mobile app is also functional. So the requirements and challenges. You need dedicated mobile devices. Most of these mobile device clouds, they have a public cloud offering. We cannot really automate moving those IoT devices there and then magically make them connect to the correct device. It's not a use case we can automate easily for public cloud. That means it has to be one of these private dedicated devices. There's a lot of work also on the security side of things. How do we ensure that nobody else in the public cloud or anywhere nearby the data center is able to see which IoT devices are there. Sometimes these IoT devices are so fresh that they're not even released yet, and these companies care a lot about keeping it secure, the information about their app and about their devices. And when thinking about the automation for these devices, you cannot depend on the fact that there are data center engineers there, and you cannot expect that those guys are going to touch your IoT device every 5 hours to make sure that they have a battery in charge and making sure that it's connected. So we need to find a software way and remote way of doing the same work. And this is something that we also had to consider with the companies we're working with for the proof of concept. We had to ask a lot of tough questions from them. Okay, did you guys realize that there's nobody actually there normally? They're going to check faulty devices, but the expectation is that these devices can be fully controlled remotely, right? So they had to, these companies, they had to go back and figure it out. So this is not something we can solve as the mobile app device lab. We cannot fix it for them, how to manage their own device. So it does take quite a bit of effort to ensure that the idea makes sense, that their device is compatible actually for this use case. And these are the kind of the basic requirements. Can you remote control also without the Bluetooth? How do you do that? Is there some kind of USB cable we can hook it up with, or some other solution that you can do remotely? Does the IoT device actually function while it's charging? Many of these devices, when they're charging, they shut down the Bluetooth part of the functionality, because the expectation is that this watch on that table, well, it's not doing anything, so it doesn't need to actually be connected, right? Well, for the test automation use case, yes, it actually has to be. It's always charging. We cannot change the battery every 2 hours, or we cannot just put it charging and then remove that charge. Automating that part doesn't make sense. So we had to ensure that these devices can also function like fully while it's charging. And lastly, like, how do you update these IoT devices? You need to be able to do that remotely, not via some very weird, like add a specific cable to it and push some firmware update. Hopefully you're able to do those kind of updates remotely, so that we don't need to worry about it. And here's a very high-level architecture image of how the setup would look like. So if we look at the bottom left, there's the test system, or let's say the tester system outside of the whole service. And they would use some tool like Appium to command the mobile devices. So on the right side, we have the Sauce Labs infrastructure. So you would use Appium to command the mobile devices, do the test automation of the app. But at the same time, you need some remote way to control the IoT devices. So this section is completely new in the whole idea. So the Appium part, that's already done. That's already well tested, well working. But how do we figure out this part, and how do we control the IoT devices, and how do we ensure that we can on-demand connect and disconnect these devices? So these are the problems we're working on and working with these companies right now with our proof of concepts. And of course, there's some type of VPN connection most likely needed. Depending on the type of mobile app, most likely you need to connect to some kind of staging backend or some kind of test environment rather than just internet access. And looks like I'm out of slides, and we can go to questions and answers. So thanks for paying attention, and do we have any questions or discussion you guys would like to have? Yep.
So we have connected a Bluetooth device in the cloud, and it's cool, yeah. But how we be ensure that device get some hook, or how we will trigger some changes from Bluetooth device. Like we have Bluetooth controller, like heavy duty, I don't know, and its device should notify web app or mobile app when harsh break take place. How to automate this part?
So you would like to make this IoT device trigger something on the app? Is that the question here? Like how can you force the device to talk to the app on its own?
Not to app. We should have an interface to trigger the action in a device from the cloud to receive a notification inside the mobile application.
Right. So if I go back to the infrastructure image here, so to be able to control the IoT devices, there's two things here. One thing is the expected Bluetooth connectivity with the mobile device, but the other thing here we see is this control device. So this could be anything. It could be a laptop in the data center which the customer has direct access to. So the intention is that the tester from the company has some kind of tunnel to a machine, a laptop or a server that has direct connection to the IoT device. And this was one of the questions, like how do we control the IoT device? Is there some kind of USB cable that needs to be hooked up to that machine? Or what is the main way for us to control the device remotely? So using this method, you would have the possibility of also enforcing things on the device. Maybe enforce it to do a reboot or whatever makes sense for that device. Thanks, good question.
Thank you for your talk. I wonder what are the limitations of this schema in terms of scalability? Like, is it like one per one connection between mobile device and IoT device?
Okay, so how does it scale? I think the idea here is that depending on how many private devices you have, it could be that you have only a couple IoT devices and then let's say 10 or 15 private devices, which are the core devices that matter to your business the most. In that case, we're working on a solution to be able to switch the mobile device and the Bluetooth device, like switch the mobile device. So you can check all the iPhones, for example, or all the Samsung devices. So the simpler way would be the one-on-one, but I think we're trying to figure out a way to also switch between those mobile devices.
Okay, and one more question. So if we consider some real business scenario, like when the user uses his wearables, like kind of IoT device, let's say it's like the essential device for this person. Maybe it's impaired person or something like that. So are we talking about also some types of non-functional testing in this in the way this user may use his device, whether it's accessibility testing or even in terms of, okay, if something happens with device, how can he like send a signal to maybe some medical center, whatever. So
you're thinking like the healthcare side of example?
It's one of the business scenarios. So
yeah.
I wonder, is it more like functional testing only, or we can elaborate, and whether you have as a part of your POC some kind of these non-functional scenarios?
I think the main idea here is the functional testing and enabling the full test automation of the mobile app together with the device. So that is the main focus here, the functional testing. I'm not sure if it's viable to think about the non-functional testing, because, as I said, there's nobody there to actually verify. It sounded like this could be maybe a manual test case, or like a typical, where you actually have to verify it's doing what it's supposed to. So I would say it's on the functional testing, that's the focus, and it's the mobile app we're testing here, not the IoT device.